This video talks about acceleration. The objective of this video is to learn what is acceleration, what is average acceleration, study the position time graphs for motion with positive, negative and zero acceleration, what is the formula for final velocity of a body, and velocity time graphs for motions with constant acceleration. We know that the velocity of an object in general changes during its course of motion. But how do we describe this change? Should it be described as the rate of change in velocity with respect to distance or with respect to time? This was a problem even in Galileo's time. It was first thought that this change could be described by the rate of change of velocity with distance. But through his studies of motion of freely falling objects and motion of objects on an inclined plane, Galileo concluded that the rate of change of velocity with time is a constant of motion for all objects in free fall. On the other hand, the change in velocity with distance is not constant. It decreases with the increasing distance of fall. This led to the concept of acceleration, which is defined as the rate of change of velocity with time. The average acceleration a bar over a time interval is therefore defined as the change of velocity divided by the time interval. That is, a bar is equal to v2 minus v1 by t2 minus t1, which is equal to delta v by delta t, where v2 and v1 are the instantaneous velocities or simple velocities at time t2 and t1. It is the average change of velocity per unit time. The SI unit of acceleration is meters per second square. On a plot of velocity versus time, the average acceleration is a slope of straight line connecting the points corresponding to v2, t2 and v1, t1. Since velocity is a quantity having both magnitude and direction, a change in velocity may involve either or both of these factors. Acceleration, therefore, may result from a change in speed with the magnitude, or change in the direction, or change in both. Like velocity, acceleration can also be positive, negative, or zero. The position time graphs for motion with positive, negative and zero acceleration are given here. Note that the graph curves upwards for positive acceleration, downward for negative acceleration, and it is a straight line for zero acceleration. If velocity of an object is u at t is equal to 0 and v at time interval t, then we have average acceleration is equal to v minus u by t, or we can rewrite the given equation as v is equal to u plus at. Let us see how the velocity time graph looks like for some simple cases. Consider motion of a car between t is equal to 0 and t is equal to 10 seconds in the given graph. Here, the object is moving in a positive direction with a positive acceleration, and the velocity time graph for the motion of car with constant acceleration looks like this. Now consider the motion of the car between the time seconds 18 to 20. In this case, the car is moving in positive direction with a negative acceleration, and hence the velocity time graph looks like this. Now consider the motion of a car from O in negative direction with increasing speed. Here the car is moving in negative direction with negative acceleration, and hence velocity time graph looks like this. Now consider the motion of a car from point O to point Q till time t1 with decreasing speed and turning back and moving with the same negative acceleration. Here the car is moving in positive direction till time t1 and then turns back with the same negative acceleration. This is how the velocity time graph looks for the motion with constant acceleration. In this video, you have learnt acceleration is the rate of change of velocity with respect to time. The average acceleration a bar over a time interval is defined as the change of velocity divided by the time interval and is given by the formula A bar is equal to V2 minus V1 by T2 minus T1, which is equal to delta V by delta T. The position time graphs for motion are curved upwards for positive acceleration, downwards for negative acceleration, and is a straight line for zero acceleration. The formula for final velocity of a body is given by V is equal to U plus AT, where V is the final velocity, U is the initial velocity, A is the acceleration reached in t seconds. Velocity time graph for motions with constant acceleration look like this for motion in positive direction with positive acceleration, for motion in positive direction with negative acceleration, for motion in negative direction with negative acceleration, for motion of an object with negative acceleration that changes direction at time t1. Thank you.